This module looks at converting between different types of variables between the others when you're doing assignments. So this may include between different types of numbers. So when writing programs that perform mathematical computations, you may need to convert some number types to others, such as an int to a double or a double to int, and you may be required to make calculations involving more than one type of number that may be assigned to a variable of a different type. You can use typecasting to convert a number of one type to a number of another type. So returning back to our rectangle area example, here I have all integers, but let's say if I wanted to change width to be a floating point number, so of type double, then maybe I want my width to be 2.5. Okay, so instead of an integer, now I want to set my width to be 2.5. I'm going to keep the area as an integer, so I still want my output to represent an integer, except I'm going to use a decimal number for my width. Now, if I run this program now, this will produce an error. So I'm trying to store the value of length times width, which is an integer multiplied by a double, which I'm then trying to store inside area, which is of type int. So I'm getting a type mismatch error. So it's telling me that I have something, or there's a type in here in this calculation that is not compatible with where I'm attempting to store it. And this is where typecasting comes in. So this will allow me to keep the width as a double type, but allows me to cast or change or convert that double to an int. So if I put int in brackets in front of width, this is where I'm typecasting that value. So I'm telling the compiler that I want it to treat the variable width as an integer instead of a double type. So now if I run the program, it allows the calculation to be completed and it gives me the area of the rectangle. Now notice it gives me an area of the rectangle of 20. There's a reason for this. So the code here shows a multiplication expression involving an integer and a double. Now the typecast is used to cast the double as an int. Otherwise it shows us an error, as I showed you before. But now when you cast a double to an integer, the value is actually rounded down to the nearest integer. So this code would convert the number 2.5 to 2, which is actually incorrect when we consider the rules for rounding. So this is known as truncation. So by setting the double to an int, it truncates the number, which effectively means remove anything after the decimal. So instead of 2.5, it becomes 2. So my calculation becomes the value of 10 multiplied by a value of 2. That's why I'm getting an area of 20. Whereas we know if we wanted to do 10 times 2.5, that should give us an area of 25. Now, if we still want to stick with the value of 2.5, but cast it as an integer, we want to use the proper rules for rounding. So in order to cast as an integer and to round properly, 2.5 as an integer, when it's rounded, is actually 3. So what we can do to make sure that it rounds properly is we add 0.5 to the double type variable so that it rounds to 3. So this would actually give me the proper area when the cast is done properly with rounding. So the area of this rectangle would actually be 30, because rounding 2.5 to the nearest integer should be 3. It shouldn't be rounding down because of the 0.5. Casting becomes very useful when you are doing decimal division of integer values. My output here tells me that each person will receive 2.0 slices of pizza. So the result of taking 5 divided by 2 gives me a value of 2. And then since slices per person is type double, it shows as 2.0 in the output. Now, when you take 5 and you divide it by 2, the decimal value should actually be 2.5. So when I do integer division, I get a result of 2.0. But I can alter this so that I'm actually doing decimal division, which will then give me a value as a decimal. So if I typecast pizza slices and people eating as double type, so this is known as decimal division, this will give me a different result. So I'm going to comment my previous line. Okay, so now I'm just running this expression. So typecasting pizza slices and people eating as double type, and then storing the value into slices per person, which is a double already. So now my result would be each person will receive 2.5 slices of pizza, which is the result when you do decimal division. Typecasting makes a programmer's intentions clear and may even make bugs easier to find. Returning to the rectangle area program, since I'm multiplying a double by an integer in the area calculation, it may make more sense to switch my area to be of type double. Now in this case, now I don't have to typecast the variable width. The int data type has less precision than a double data type. So if I take the int type length, multiply it by width, this is still going to run in the Java program since length has less precision. You cannot put more precision into less precision, but I can put less precision into more precision. So I can use int, an int type multiplied by a double, and store it into another type or another variable that's also of type double. So if I run this program, this gives me the area of the rectangle as 25.0 as expected when you multiply 2.5 times 10. This is what is known as implicit casting. So length here was actually cast as double since I was storing it into a double type variable. So it's not necessary if you're going from, if you're storing an int multiplied by a double into another double, or going from less precision, storing it into larger precision, it's not necessary to cast, but it is good programming practice to cast anyways. This will still give me the same result. This can also help make it much easier to find any bugs in your program.